All right. Come on, everyone. Um, so is there any big questions on 2.1 and 2.2? Are we pretty good with those? All right. And that is this. Qualitative or quantitative? What is it? Quantitative. Why? Numbers. Okay. Is it discrete or continuous? Why?
Because well, the values in between whole numbers happen.
Very good. Yes, that would be the difference. So we're talking about TV sets, so 1.5 TVs doesn't make much sense. So here's an interesting question. If I wanted to know the number of bathrooms in a house, would that be continuous or discrete?
Discrete.
Why?
Because it moves up.
But doesn't.
Well,
You can have a half bath.
but it can still continue moving up half.
Right. Good. Okay. That was actually why I was asking that. Because we seem to focus on the halves, which I said. But you can have a half bath, but you can't have a quarter bath. So yes, those would still technically be discrete because they jump. Very good. Okay, so what we're going to look at today is ways to graph and work with quantitative data instead of qualitative data. So, but a lot of the same things that we did will work with it. So one of the things that we're going to have to be able to do is still be able to identify groups of data and be able to figure out relative frequency and those type of things. So we have a few different ways that we can do that when we're talking about numbers, though. The first one is just called single value grouping. And that's actually exactly what we did when we did qualitative data. So that was just, I'm actually not going to have you go through and count them all up and everything else. So if we took that data and we counted them all up, we would get our frequency of how many of each of the TVs. And then we could figure out our relative frequency from that. So single value grouping is no different between quantitative and qualitative. You're just counting them all up and figuring out the relative frequency from there. Right? And we can do all the same graphs from this. We can make a pie chart, we can make a bar graph, and everything else from it. So that would be no real difference. The next one we go into, though, does change. The next one we have is known as limit grouping. So since they're numbers, we can group them together. So we can kind of do this with qualitative, but it's not really the same. So when we're looking at limit grouping, we're grouping groups of them together. So we have a lower class limit and an upper class limit. So for example, if I was looking at the TVs, I could say 0 to 1 TVs, 2 to 3 TVs, 4 to 5 TVs, 6 plus TVs. Like that would be a limit grouping. So the lowest limit would be the first number, the upper limit would be the last number. From this to what we're going to look at next, that upper class limit changes slightly, but we'll talk about that in a minute. The next thing is the class width. The class width is the difference between the lower and the limit and the upper limit. Those have to be the same for each problem. So you can't have different class widths in your groupings. And then your class mark is the average of the two class limits of the class. So if I'm looking from 1 TV to 5 TVs, I would put the mark at 3 because that's the average of it. So I'd have the bar from 1 to 5, but there'd be a little mark in the middle. That's just identifying the middle value. So when we're looking at if we're going to be doing weighted averages and stuff like that, we would use the average of them, which we'll talk about next week when we look at chapter 3. I'm sorry, I'm fighting a massive headache, so that's why I'm a little scattered today. All right, so let's look at this data. So first thing when you're looking at it, you still have to be able to identify if it's quantitative or qualitative, and if it's discrete or continuous, because those change what we can do with it. So days to maturity for short-term investments. So this is, in this case, is this group of data qualitative or quantitative? It's quantitative, it's numbers. It's discrete or continuous. It's discrete how it's listed. You could make a claim that this would be continuous just because the value, like you could have a half day and stuff like that. But the way that it's listed and given to us, it's discrete data. All right. So let's do it this way. So the first thing we want to look at is it wants us to do limit grouping with grouping by tens. So when we're looking at this, since we're doing it by groups of 10, we don't want to do 0, 10, 10, 20, things like that, because I might not need all those. So what's the lowest value in this graph, in this chart? Okay. Give me my pen. Hold on. Of course. Okay. We'll just do it a different way. All right. So I've got 36 as my lowest one. And what's my highest one? 99. Okay. So my first group of 10 will be 30 to 39. Okay. Notice I did not go to 40. You can't have the same number as the class highest one and the lowest one, because then the question is, where would I put that number if it appeared in both of them? So you want your class groupings to be broken down so that's not the same in both of them. So my class groupings would be like this. And once we start, we do every single one of them. Even if there wouldn't be any in that range, we would still put it at that point. Okay. So we got 30 to 39, 40 to 49, 50 to 59, and all the way up to 90 to 99. Now, since it's grouping, we're going to count each of those in those groups. So go through and count up those. All right, now if we counted them up, we'd end up with this. So we have our frequencies of this. One of the nice things about doing the limit grouping is it prevents us from having a bunch of single values. So in this situation, we had 40 values, but a lot of them were just ones. Unlike the TV example where there was groupings of them, like there was a lot of ones, there was a lot of twos, a lot of threes, and so forth. This one, we have a bunch of different values that are going to be there. So single value grouping wouldn't make much sense. By grouping them, we can start to see what's going on in that situation. So, but after we group them, everything else is the same. You have your counts. We can do our relative frequency from that. You can still do a pie chart from this. We can do a bar graph, but we're actually going to do something a little bit differently with this one because it's a grouping. So, all right. Next one. So we got 3 different types of groupings we're going to do. The next one is known as a cut point grouping. So in the last problem, we did 30 to 39, and then we did 40 to 49. Is 39 and 40 like are they? Would that be a cut point? So in the last problem, there was no difference between 30, like 39 is there and 40 is there. They were discrete values. There was nothing between 39 and 40. When we start to look at data that is continuous, however, there's values between 39 and 40. So when we use cut point grouping, my value is going to go, it's not going to say 39, it's going to say under 40. Because that would be every value under 40, but not including 40. So it's like that less than instead of less than or equal to type thing. Okay, because this way, anything like 39.999 would still count in that respect, but 40 would be in the next one. So your lower class cut point is the same as in the limits, the lower class. The difference is in the upper class. The upper class is the smallest value that can go to the next higher class. And that's why we say like under 40 or under 50 or under 60. The class width is the same. The class midpoint is the same. All right. So let's look at this set of data. So these are weight in pounds of 37 males from 18 to 24. What makes this data different than the other data that we've looked at? There's decimals, so it's probably continuous. All right. There's definitely values in there. And even though we only went to one decimal place, it's weight. We could technically go to more if we had a more accurate scale in that situation. So this is continuous data. It's still quantitative, it's still numerical, but it is definitely continuous. So when we're counting these up, what's the lowest value? Yeah, we have 129.2. It's the highest value.
278.8.
278.8 is the highest one. All right, so if I wanted to break these up into groups of 20, so my class width is going to be 20. What's going to be my first class width? Or what's going to be my first class? Nope, we're going to do groups of 20. Yeah, it'd be 120 to 140 and or to under 140. And that's how you're going to list it. All right, so I'm going to just do it on this screen. So we've got 120 to under 140, 140 to under 160. So you can start to see how that's how we can decide with the continuous data is that we have it's the under 140. So 139.9 would still count for that. 160 to 180, 180 to 200, 200 to 220. And then notice how, so when you were looking at the data, quite a few you're picking that 200, like the 218, those things, and you missed the 271. I still need to put the 220 to under 240, the 240 to under 260, because I need the 260 to under 280 because I have a piece of data there. So we're still going to have those classes in there. I can't skip them. So I also can't do 220 and up. Notice even the 260 to under 280 is not and higher. Because if I do and higher, then the data is, then the class widths are not identical and they have to be the same. Okay, that's one of the things that you'll see quite often. Actually, let me see if I can find a graph real quick. This will actually be a really good deceptive graph.
Do something. This is what must be done in order for this equation to work.
Yeah. So let's look at this one. See if this will work well. Yeah, this one works well. So here's a good graph for this because this is used quite often. Now, this is a graph of the data, not the actual, like the chart of the data, but it's the same concept. So looking at the graph, it looks like pretty much all the income groups are about the same. If you just look at the bars, there's a couple in there that are higher. But the bars are all pretty straightforward and equal. All right. Now let's look at the classes. I have under 15,000. Okay, that's fine. 0 to 15,000. I have 15 to 25,000. Okay, so I had 15,000 for my first group, and now I'm at 10,000 for this class width, right? So now we're looking at a smaller group of people. 25 to 30 to 34, so that's okay, that's a 10. 35 to 40 or 50, okay, now I'm back to 15. 50 to 75, okay, now I'm up to 25. 75 to 100,000, okay, that's another 25. Now 100,000 to 150,000, okay, now I'm up to 50. 150 to 200, okay, now I'm at 50, and then 200,000 and over. So that's 200,000 all the way up to billions. So you can start to see how that when they change that class width, you can start to get a different view on what's really going on. Where if they were all 50,000, all of that would be one group. So that'd be 11, 19, 27 and 36. So that'd be 36% from 50,000. This would be 27%, and then 16%, and then 8%. And then if I broke this down, you'd start to see it, these would be very small in those respects. So you could start that now that changes how this graph looks, changes how the data looks. Okay. So that's why it's so important to show accurate data. You want your class widths to be the same, because when they're not, you start to skew that information. Okay. So that's also why you need those blanks in there. Like sometimes that happens, and that's okay. It's just you want that representation. All right, so we've got 3 different groups of data, or 3 different grouping methods that we looked at. Single value grouping works when it's discrete data. You also, this is very similar to qualitative data. And you want them to have a very small number of the distinct values. So you don't want to have a lot of different values. So typically when you're going to do single value grouping, they're all normally under 10, things like that, because they're very easy to just count up. Limit grouping, the only real difference between limit grouping and cut point grouping is distinct or discrete versus continuous. So, and the big difference between single value and limit grouping is I have a variety of different values that I'm looking at. All right. If we're looking at this data, what would be one of the ways that you'd want to represent this as a graph? What would be a good graph to use to represent some of this data? What are some graphs we've talked about? Yeah, we have the bar graph, or it was the line graph, the points on there, which is kind of a bar graph. It's just we just didn't draw the line down. Okay, so a bar graph, and what was the other one? Those are bar graphs. That's a bar graph. Yeah. What's another one we talked about? Pie chart. So both those can be done with this. But we're going to look at a very specific type of bar graph. It's called a histogram. All right, so the big difference between a bar graph and a histogram is that the bars touch. Okay? Because that connection means something. It means the data is connected at that point. It's not, there's nothing between those points, those values. Okay? So we're looking at a bar graph. There was no real meaning from one bar to the other bar. So if we're talking about colors or things like that, like between those 2 colors, it really didn't have any meaning. So we didn't want the bars touching. However, when we're looking at numbers and we're grouping things, or even if we're not grouping things, if we're doing single value grouping, when we put the things together, it means there's nothing between those 2 that actually has meaning. So like 0, 1, yes, it's like we're going to touch them because there's no half, or 1 to 2, like there's no 1 1/2, so they can touch. It's like those, there's nothing between those, so we can have them connected. If we're doing class groupings, we're showing the fact that those classes actually touch at that point. Okay, so that's really the difference between the two, and people use them interchangeably all the time. It's kind of like what I showed you at the very beginning with the line graph where we connect them. It's like people like that, but there really is actually a difference between the two. All right, so to construct a histogram, it's in essence the same as what we did with the bar chart. You obtain the frequency or relative frequency, you draw the horizontal axis, you place the bars on it. For each class, you're going to construct the value that goes with it, and you're going to label the bars with the classes. Sometimes you'll label the bars, sometimes you'll label the midpoint. It just depends on how that person wants to represent it. You can do it as a variety of different ways. So here are some of the histograms for the problems that we just looked at. So here's the TV set problem. So now the TV set problem we had was single value grouping. So it's the same two graphs. One's just the frequency, one's just the relative frequency. So you see how they're marked. They got the 0, 1, 2, 3, 4, 5, 6 on the bottom. And then on the vertical axis, we have our design for whatever we're looking at in that situation. So we have that breakdown there. All right, let's look at. So this is the short-term investments. Now this one, we did class groupings. So we grouped them by class. What's the difference between this graph, how this graph's set up, and how the TV graph was set up? What's one of the first things you notice about them? Okay, what do you mean by how the x-axis is laid out?
So on the TV graph,
Okay.
but on the short-term investments, there's one number that starts the column and one number.
Very good. So yeah, so that, remember, those were my classes, right? So in this way they set this one up, they didn't actually put the numbers in the middle. The bars were in the middle. So this bar represents from 30 to 40. This bar represents from 40 to 50. So we didn't have any numbers in the middle, but the bars were there. And that's fine. That's another way to set that up and look at that. Let's look at the, wait. This one, they did not. All right, so what's let's look at the, actually I'm gonna put them both up here because I want you to look at some differences. What's the difference between this one and the one we just looked at? So did they still do that between the two numbers? Yeah. They could have easily done the middle. They could have done 130, 150, 170. They could have done those in the middle, like the first one. They just chose not to. What's an piece in this one that looks different? Yeah, so, and the one we looked at the days to maturity, they put that there, right? That 0 to 10, the 10 to 20, the 20 to 30. They have those there. And this one, they chose not to. They started the graph really at 120. And they put a little break thing there. That's just a personal preference, and it really depends on the data. It would have been kind of a pain to have 0 to 20, 20 to 40. Like that'd been a bunch of blank space at the beginning. So it doesn't make sense to put all that stuff there. Starting off at 120 makes more sense. When the days to maturity, just having the 2 blank spaces there didn't really make that big of a difference. Or actually 3 blank spaces. Because it really isn't that far out. So again, it's just a preference in that thing. They didn't put a break in the middle graph. You don't want breaks in the middle because that does change views. So you do have the blank space from 220 to 240 and 240 to 260 in that one there. You do want to represent, though, that there's a break. So you don't want to just start off at 120. You put a little line, a little squiggly, whatever. You want to represent that there's a break there, though, that there's no data before that point. Okay.
Has to be healthy now, would be a children's hospital.
Yeah. So it's, well, actually, in this situation, it doesn't really make much difference. Like, they weren't really doing a study or anything else like that. But yeah, if you're looking at trying to use this to show patterns in a population, then yes, you'd want to make sure that it's a random sample, and you wouldn't want to skew the data one way or another. So yeah, you wouldn't want like completely malnourished, yeah. But there's somebody that was 278 pounds, which most people would not consider to be healthy. So it's not necessarily. Yeah. So yeah.
Just to explain the graph.
Right. Yeah. This was literally just looking at graphs. We're going to get into a lot more of that stuff later on. Oh no, you're fine. It's like, it's good questions.
I find it.
If it was a horrible question, I would have ignored it and moved on. No, I'm just, no, it was a good question. All right. So does everybody understand the difference between a histogram and a bar chart? Good. So what's this? Bar graph. Very good. Why? Because it's not touching, and it's even if it was touching, it's a horribly designed histogram because the classes aren't the same. But good. All right. Next graph we're going to look at is called a dot plot. So a dot plot is a graph with a whole bunch of dots on it. It is not a scatter plot. Okay. And when I show you the graph in a second, I'll explain the difference between the two and why that's not. So you're typically going to use a dot plot when you have it's discrete data. So you're not going to have decimals and stuff like that in there. And you typically use this a lot of times with single value grouping. You can do it with class grouping, but it's not typically done as much. Nice thing is this one, it almost makes like a tally, so you can actually start to look at and do other things with it. We use it because it's really easy to start to see how patterns form in data. So it's kind of like, instead of doing the tally marks, it's similar to that, but it's made a graph, so you can actually start to look for patterns and see if it's a normally distributed and those type of things, which we'll talk about in the coming weeks. If you look at how to construct it, what's missing from that was in the other graphs that we had done? Vertical axis. And that's why it's not a scatter plot. So scatter plot, the points represent the X and the Y. You have those two pieces. It's a representation between those two. A dot plot is just the horizontal axis. So that's a dot plot. Okay. There is no vertical axis. The points count up. It's like you're literally just like tallies. So if we were going to go through and count these up, that'd be a tally mark. Then I have 3 tally marks for that one. The only difference between this and just doing tally marks is you don't have the values next to each one. they're broken down into points here. So like we've got 190, so 195, so that's 197 and 199. So I had 3 199s. 1, 2, 3. Then there was a bigger gap here, and then I've got the points there. So you can start to look for clusters and patterns and those type of things. You can kind of do this as a class thing. At that point, it's like, okay, I've got a class of 100, so I've got 4 there, 200 to 210. I've got 2 there, 210 to 119. I've got there. So you can start to look at how you can start to cluster the data and then do those the groupings, either the limit groupings or the cut point groupings. But it's just another way to display data. USA Today like to use this a lot. So USA Today had their graphs in the corners a lot of times, and they'll do these with instead of dots, they'll put pictures. So like big pictures of cars or whatever else broken down. So it's like you do see some of those situations there. It's not horribly useful, but it is a graph that does show up and has its uses to kind of display data. Next graph we're going to look. Anybody ever heard of a stem and leaf plot? Okay. So a stem, I'm going to move this a little bit. Hold on. So a stem and leaf diagram, again, starts to help us cluster data and look for patterns. The big difference between it and a dot plot are individual points. A stem and leaf plot groups them into groups of 10. So when we're looking at doing a stem and leaf plot, you're looking at the last digit is the piece that you're going to be graphing in there. So those are the leaves, and the stem is the digits, everything before the last digit. So it could be 1, it could be 2 places. That doesn't make much difference there. So let's look at one to make sure so it actually makes sense. So here was our data again from our 40 short-term investments, and this would be what my stem and leaf would look like. So let's see if I can find the other graph because I did this one already. Do that. All right, so when we were looking at this data, right over here because we don't really need it. This is what we had done before. We did the tally marks. And then we did our relative frequency and stuff like that. You can start to see. So 30 to 39, I had 3. So that. The difference between the stem and leaf and the tally marks is I actually still have my data. The ones in the 30s had 36, 38, 39. So not only do you have your tally marks, we also have the actual data that we can look at, which is kind of helpful. And it's sorted. It's in numerical order. So it takes all that data, puts it in order. So then I can look at doing medians and means and stuff like that with it. I have one between 40 and 49, 47. I have 1, 2, 3, 4, 5, 6, 7, 8 there. So we can still get the nice like curve pattern that we're going to start to look at going forward, and we're looking for how that data is organized and patterns that are forming. And that's really what we're looking at with this. We can start to see that there's a bunch of data right in the middle here. There's a little less on the ends. Which also is when you're writing them down, you want to kind of write them in columns so you can start to see that. You don't want to crunch things together in one place because then you don't get to see that pattern forming. So when you're designing them or doing them on a computer or typing them, it's like you want everything organized and lined up. So this is a stem and leaf plot. We can do stem and leaf plots a couple different ways. So these are cholesterol levels for 20 high-level patients. So here's 2 different stem and leaf plots for this data. What is the difference between the 2, do you notice? Yeah, so the left is a traditional stem and leaf plot, right? It's 1990 or 190, yeah, 199, 200, 202, 203, so forth. It's just a one place. The second one, the one on the right, it splits it up into, so there's multiple of each step. Now, it's not random. As you said, it's groups of 5. So the first one is 0 to 4. The second one is 5 to 9. So it's grouped in that respect. So again, like both of them are accurate stem and leaf plots. The second one just shows you the data a little bit better organized, so you can see a little bit more patterns forming in it. So because we have a bunch of data grouped in the 20 to 21 or the 200 to the 210s, and then so this way it kind of spreads that data out a little bit more, so we can start to look at it a little more granularly. Okay. So again, same kind of concept, same things. It does work either way. It's just another way to represent that data. All right. Any questions on those graphs? Were any of them something you've never seen before? All right. So a lot of the stuff is still stuff that you've seen at some point. We're just kind of formalizing it, a lot of it. Good. Good. Stem plots you don't normally see very often. Box and whiskers, one that you'll see quite often, which we'll actually talk about a little bit later. I've seen this one when teachers are trying to make, like when they're starting to look at organizing data, especially in elementary and middle school, they'll do mobiles and they'll do these because it's like you can have things hanging and stuff like that, which is kind of cool. We got my parents it was like a birthday calendar thing, and it was basically all the months, and then underneath you hang hearts for all the days that are birthdays and those things. So it kind of basically made like a nice stem and leaf plot for the months. So you do see it. It's just, it might not be represented in this way, but you've probably seen this concept and stuff before. No, they use the dot plots kind of because they'll show little pictures instead of dots.
When you said that, then I remember seeing it.
Yeah, the USA Today, like, so this is an old thing when you actually used to get physical newspapers. USA Today was a newspaper, and they used to have like the articles, and on the bottom corner of every like main page, they'd have a graph. Their graphs were horrible. Like they were the most misleading and horribly made graphs ever, but they were pretty. They had pictures, they had colors and everything else. It was like USA Today was one of those newspapers that everything was in color, where like most newspapers were just black and white. So they popped because they were in color. So those graphs were there, but they were horrible, horrible, horrible graphs. Like I used to use all their graphs for my misleading graphs. It was all USA Today graphs. But they don't do that as much anymore. USA Today is still around. It's a website, but it's like the graphs aren't as prominent anymore. All right. So one of the things that I've been starting to talk about when I've been looking at the graphs is patterns. So when we're looking at graphs and data and stuff like that, if we start to look at the last couple of graphs, the dot plot and the stem and leaf plot, we started to notice kind of how things were shaped. So if we look at, let's see if my pen's going to work now. It's still not going to work. I'll figure out why that's not working afterwards. All right. So we can look at this data here. You can start to see how it makes a curve. Okay. Or if we look at this one, it kind of goes down and goes back up. So we can start to look at how these start to curve. And it's like in this one, we go up, we go down, we go up. So that pattern or those curves have meaning. And the first thing that we're looking at is modality. So modality is kind of like mode. The things that appear most often are the ones that would be my mode. So, but we're looking at how the peaks basically in the graph. So if you have unimodality, it's just one peak. Most of the stuff that we're going to be looking at going forward past chapter 3, and we're starting to really look at the actual statistics and stuff and the new stuff that you haven't heard of before. Most of them are going to be designed as bell curves, and bell curves have that one peak right in the middle. And we have the left and right side are less. So those are unimodality. Bimodal, we have 2 peaks. It doesn't necessarily have to be symmetrical. It doesn't have to be one on one side, one on the other. It could be they're both on one side and it's skewed to one side. It's just there's 2 peaks. And then we have multimodal is when there's multiple peaks, more than 2. So we're going to see how this data really starts to work and how we can start to use it to predict and to look at different concepts and different things. The next thing we want to look for is symmetry. There is a couple different types of symmetry. The bell shape, you're going to hear that a ton, the bell curve. So this is why you'll never hear me curve grades. Because a true curve is a bell curve, which means that there'll be an equal number of people getting A's and F's. Is a true curve. The vast majority of people get C's. That's the middle. That's the average. So what we see now, if you were going to balance grades, that middle has shifted. And we're going to talk about what that means in a minute. So, but symmetrically, we have our bell curve, same thing on both sides. What's the difference between a bell curve and a triangular curve? So what's the 2 sides of the triangular curve called? Now think back to your algebra class. What do the 2 sides of the triangle make? Just what's one side of it make? It's a what? A line. So what kind of function is it? Same thing, starts with line, linear. All right, so in a linear graph, why is it linear? What's the same? It doesn't change. It's the slope. Okay, so when you're looking at a triangular curve or triangular symmetry, the sides are linear, the slope doesn't change. So it's going up in equal fashion all the way through, where the bell curve doesn't. It changes as it goes out. So that's a large difference. It's like if we look at the section over here and the section over here, you still have 50%. But that the vast majority of the chunks in the middle here, where this one is all equally distant. So like from here to here is the same as there. So it's equally broken up. And then the last one, you have everything's basically the same. It's just a horizontal line. The last thing we want to look at is skewedness. And this is where I was getting to with the grading. Which direction do you think grades have been skewed towards? The left or the right? The left. Grades have been skewed a lot higher. No longer is a C a good thing. No longer do people like, yeah, I'm happy, I got a C, I'm average, I'm good. It's like now most people, if they don't get at least an upper B or even a low A, it's like they're not happy. So grades have definitely been skewed. If we look at right skewed and left skewed, because this is actually going to become a very big thing going forward, and understanding what it means is important. Which one? So if we're looking at right skewed, so you're looking this way, right? I'm going to do it your way. This is right, correct? If you're looking at this graph, would you consider this to be right skewed? You'd say left, because that's where the bubble is. We're not looking at the bubble. We're looking at the line. Because, and that's the reason why, is the next chapter we're going into, we're going to start looking at mean, mode, median, and averages and stuff like that. This is right skewed because it pulls the mean or the average to the right. So if we're talking about, let's talk about home prices, or actually, let's not talk about home prices. Are hard, a little hard. Let's talk about income and wealth. What's the wealthiest state in the country? If you're going to think about it, what would you consider to be the wealthiest state in the country? It actually used to be Connecticut. Connecticut was the wealthiest state in the entire country. Right, Litchfield County, in certain areas in Litchfield County, have more wealth today, right now, than Beverly Hills does. There's more wealthy people living in the Greenwich area, in that area, than Beverly Hills. Okay? Or Silicon Valley. Actually, the wealthiest state in the country right now is New Jersey. Then Connecticut, then California. So, however, none of you would have thought that. And it's like, wait, what? Yes. And it's because the wealth in that area is so high that it right skews the data. It's pulling the average from the cities that are very low to the right. Okay, that's what it means by right skewed or left skewed. It's, yes, there's a ton of data here, but this data over here is pulling that average this way. The median's here, but the mean is this way. That's why it's right skewed. Left skewed the opposite. The median's here, but the mean is to the left, because the little values are pulling one direction or another. So I live in Hartford, and the first thing you think about when you live in, if you think about Hartford, do you think of wealthy people? We have some of the richest houses, like the most highest priced houses in the state are in Hartford. In one street. They're like multi-million-dollar houses on one street. It's where the governor's mansion is. That one street right over by Elizabeth Park are literally multi-million-dollar houses. Those value of those houses pull the property values in Hartford to the right. This is why a lot of times you never look at mean or average for a statistical value when you're looking at housing values or income, stuff like that. You look at the median because the median doesn't get pulled as much and you won't have that right and left skew in that respect. So that's why a lot of times you see the median value or the median income and not the average income and those type of things because of this. But yeah, so when we're talking about right skewed or left skewed, you're looking at the pull, not the hump. Okay. All right. We're done with chapter 2. And you're like, wait, well, we finished chapter 2. We got chapter 3 to go, and then the test. So we still got one more chapter to go, and then our test.
When would your test?
So let's see. We got chapter 3 next week. So we'll do our review on Valentine's Day, and your first test will be the 16th. So the nice thing is the week that we do it, the review day will always be Tuesday, and the test will always be Thursday. So you'll always have that review before the test.
So next week, no problem.
Yep. So you still got time. I should have the review test done before the 9th. So this way you'll have some time before that point to work on it before you come into class on the 14th to actually work. And then we're going to do it on the 14th together. But this way you guys can practice and stuff like that beforehand. So that's my hope. All right. Other than that, have a wonderful weekend.
What's the one?
I would do, honestly, I would do the end of